All right, we're just about there, but back on my little RSA encryption thing. You know how I was telling you you can multiply two 40-digit prime numbers together? I said we have an infinite number of prime numbers to choose from. Just as a random fact here, if you take the number 2, if I said 2 cubed, everyone understand what I mean? 2 times 2? Okay. Times 2, 3 times? So 2 raised to the 77,232,917.
Wow.
Okay, take that number, so take 2 and multiply it times itself, 7,232,917 times, okay? That would be an even number. That would be an even number because it's 2 times. If you subtract 1 from that, that is the largest prime number known as of June of this year, okay? If somebody gives you a number, it's easy to check it if it's prime. There's an easy algorithm to see if it's prime. It's just there's so many numbers to look for that it takes a while. So the way they do this is that, you know, a lot of universities have computers. Like we all, you know, these computers are just sitting in these labs. So a lot of universities and colleges are part of a program where during the night, like when everyone leaves, during off hours, like from midnight to 4 a.m., 5 a.m., something like that, that computer in the background is running a check on a set of numbers. And they're doing that at a bunch of different, you know, thousands and thousands and thousands of computers, trying to look for the next prime. And some computer somewhere, in some college sitting there, hit this one in June of 2018. And a new one will come soon. You know, it just takes time, but that's, you know, we have these days like crowdsourcing, where you want to do something, you get people to pitch in. This is like crowdsourcing computer processing power. You're trying to get everyone, you know, working on the same. Now, who cares that this is the largest prime? No one really cares, right? But you got to have a largest everything, right? This is the largest prime we have, that we know of. There's more, though. All right. All right, let's get back to business here. Did I start? Yes, I did. All right, the sign-in sheet. Everyone get that? Where is it?
No.
Okay, can you pass that forward? Anyone else need it other than up here? All right, so we are going to now just kind of recap. If we have 2 terms when we're factoring, you know, difference of squares, sum of cubes, difference of cubes. That's what we're looking for. So we kind of talked about that. We have 4 terms, we're going to try grouping, right? 3 terms, we've waited till the end to do 3 terms because this is a method that I can show you. But the best method for this is not the AC method. The best method is what's called guess and check. The problem with guess and check is like everything else. Let's see, does anyone here have a hobby? Do you want to share what your hobby is? Do you want to share what your hobby is?
Hockey.
Hockey? Like what kind of hockey?
Ice hockey.
Ice hockey? Really? So when did you start playing?
When I was in the Marine Corps. 3 years ago.
Okay, so when you first got on the ice, were you like as good as you are now?
Oh, no.
No, right? It's like anything else in your life, you have to have practice with it, right? Anything, no matter what. You never, I guess some people maybe are just, what's that? I still think you have to work on it though, right? And I'm like, even like great singers have to like, they don't just come out and start, you know. They have to like work on their voice. Maybe there are some examples of things where people don't have to try and it is. But like anything else, the guess and check method takes time to get good at because it's pattern recognition is what it is. So I can't teach guess and check in one day. There's just no way I can do it. So I do have a method that I will show you to do this factoring. What I put up here are some examples. There's 7 examples of factoring. So this is written backwards. This is what I would start with. I'd ask you to factor it. It's 3 terms, right? And this becomes this, all right? So if we go through a process of factoring, these 3 terms will turn out to be this. And we can just check it real quick. X times x gives us x squared. X times 3 would give us 3x's. 2 times x would give us 2x's. So we had 3x's and 2x's, put them together, that gave us the 5, right? And then 2 times 3 gave us the 6, right? So this, I'm just showing you that all of these three-term expressions, all of these, break down to be these, all right? So I wanted to maybe look at these 7 and see if we could find a pattern and kind of to show you what the guess and check is. So imagine, we're going to act like we don't see this right now, okay? And we're going to say to ourselves, if we see 3 terms, we're going to need 2 sets of parentheses. That is going to be, no matter what, this is what we're going to start with, okay? Then, because this is x squared, I'm going to put an x here and an x here, right? That would give us the x squared. Now the next thing we need to do is look at these 2 numbers, the 5 and the 6. So I need a positive 6 and a positive 5, right? Now look at what it's going to come from. What does it come from? 2 and a 3? They're both positive, right? Plus 2, plus 3. So do you agree that these 2 numbers add up to be 5 and multiply to be 6? So that's what you have to do with guess and check, is you have to sit here and kind of guess and check. How do I get these last 2 numbers to give me a 6, right? I could use 6 and 1, but does 6 and 1 add up to be 5? No. So I'd have to kind of check, okay, does 2 and 3 work? If I make them both positive, 2 times 3 is 6, 2 plus 3 is 5. Make sense? Let's try this one. So if I do this one here, right, I'm going to do 2 sets of parentheses, x here, x here. Now, I need 2 numbers that multiply to be negative 28. And they need to add up to be 3. So let's think about that. I need 2 numbers that multiply to be negative 28. There's multiple ways I could get this, right? I could do negative 28 times 1. I could do 28 times 1. I could do negative 14 times 2. I could do 14 times negative 2. I could do, 3 doesn't go to 4. I could do 7, negative 7 times 4. I could do 7 times negative 4. See all these different combinations? You have to figure out which of these work that when you add the 2 numbers, you get positive 3. Right? And there's only one of these that works. It happened to be the last one I put down here, right? That one right there. This is the guess and check. And like I said, it takes time, but once you get good at it, that's the fastest, most efficient way. Okay, let's just verify. Multiply, I need to multiply to be negative 2 and add up to be 1. So positive 2 and negative 1. I need to multiply to be 12 and add up to be negative 7. Negative 4 times negative 3 is positive 12. Negative 4 plus negative 3 is negative 7. I'm going to erase these now because they're cheating. You know the answers. Let's try something that doesn't have that written up there and see if you can do it. Now I will show you the AC method, okay? I'm going to show it to you because I have to give some people here that aren't ready for that or have not had enough exposure to it something to fall back on. All right, so let's try this one. What if we're trying to factor x squared minus x minus 56? Now don't blurt out the answer. Who does not feel real comfortable with? Well, let me do it this way. Who feels comfortable with this guess and check? Okay? So who's not comfortable with it? Come on, don't be shy. Everyone's comfortable with it? I can give you a quiz on this right now. Everyone's happy? Am I going to have to call on people randomly? I'm trying to get someone who's uncomfortable with this to volunteer to go through the journey with me on this problem. No one? Okay.
I had a question.
Yes.
What if you have a number in front of that 8 or
I haven't given you that yet. Yeah, that'll be a little more complicated. We will do that. All right, so let's talk through it since no one wants to volunteer. You're going to put two sets of parentheses, right? And you need two numbers that multiply to be what? Negative 56. And add up to be what? Negative 1. So sometimes we do this. If you've never seen this is part of what the way AC method works, is use this little like cross. You need two numbers that multiply to be this and add up to be this. And then what you do is you put the two numbers right here. It's just a cool little, not cool, I'm not going to say it's cool, it's cute, okay? It's a cute little way of organizing your ideas, all right? All right, so can you come up with two numbers that multiply to be negative 56? 8 and 7, but one of them has to be negative because it needs to be negative 56, right? Negative 8 and positive 7. Why not the other way around? Why not positive and negative? Because then when you add them, it'll be positive 1. So this is the way you need it to be, right? So that'll work. So here you put x, and then you put your two numbers, minus 8, minus 7. Plus 7, yes, thank you. That would be wrong the way I put it up there. All right, let's do another one then. X squared minus 5x plus 4. So for this, I can do x and x, right? You need to come up with two numbers that multiply to be what? 4 and add up to be negative 5. So what are they?
4 and negative 1.
4 and what? Negative 4 and negative 1. Because they multiply to be positive 4, but add up to be negative 5. So this would be minus 4 minus 1. The good news with this factoring is you can always check your work, right? You could always like multiply this out, and if it gives you back this, then you got it, right? How about this one? Sorry. You need two numbers that multiply to be what? Negative 6 and add up to be negative 1. What do you got? Negative 3, positive 2. Those two multiply to be negative 6, but when you add them, you get negative 1. So this would become, in parentheses, x minus 3, x plus 2. Would it have been all right for me to do it this way? Yes? Right? Because this is multiplication, and multiplication is commutative. There you go, commutative. So it doesn't matter which order you do it in. Okay. Now, y'all seem like, at least the people who are comfortable with this seem to be very, very vocal and seem to understand it. But let me try something a little more challenging. How about, okay, so this is when I think guess and check starts to become a little bit hard to do. And notice the big difference here is that we have 2x squared, right? So a lot of you said you were comfortable with this. Let's see a show of hands again. How many of you still feel very comfortable with this? Okay. So if you feel comfortable, can you guide me through how you're doing it?
Do your little X thing.
So you still want to do this? Okay, now what?
And you're gonna multiply the 2 and the 5. And multiply A to C.
Okay,
And then
Divide by A and get your two factors of 2 times 5. So if you do like your X,
Oh, you want me to do this thing over here again? Is that what you're talking about? Okay,
then you put the 10 on top,
you put a 10 here and then,
negative 11 on the bottom.
okay. If you don't know what he's doing, don't worry about it. Don't, just stay tuned. I want to know how you're thinking about this, that's all.
And then you put negative 10 and negative 1.
Negative 10 and negative 1,
And then divide out by 2.
and divide out by 2 onto what? What do you mean by divide?
Then you divide like negative 10 by 2 and negative 1 by 2.
And then do that, then what do I do with those?
And then,
Put
that's
those.
right.
Okay, so this is maybe a little hazy. So anyone else doing this kind of a different way, or?
Yeah.
So what I would do is I would multiply the 2 and the 5 and
Okay.
then figure out what my factors of that is.
So
and
you
what
got
equals
10.
negative 11. What's multiplied together that can be added together to equal negative 11.
So these two numbers?
Correct.
Right. But then what do you do with those? That's my question.
Bring down the 2x.
Uh,
Oh, you said it equal, right? You do.
Okay,
Yeah. You put 2x.
let's hear yours.
Oh, I just figured out the facts and then bring down that 2x.
Okay, you put 2x here,
Yeah. And then minus 10.
minus 10.
X. And minus 1.
Yeah.
Anything else?
And you just factor it out.
Okay, so is this this?
No, the top, that second one should be
So maybe we should go through this.
minus 1x plus 5.
Minus 1x.
Yeah.
Where? Here?
Yeah. So when you factor it, like you pull out the.
You bring down the 2x squared and you
I don't know.
Okay, so look, let's do this.
without parentheses.
Is it pretty clear that when we were doing it without the 2, we were all cruising, and we all kind of had the same sort of like mindset about the way we were going about it? And now that we've thrown the 2 in there, can you see that we have a lot of different sort of approaches? Yes? Okay. And because of that, and because especially there are students in here who are still even struggling with this part, I need to give you a method that's going to work in either case. Okay? That's what I'm doing. And I can't do that because it's not an equation yet. So, all right. So now AC method, all right? I'm going to show you the AC method. If you do enough of this, right? Playing hockey for years, then you can do this. You can get, this is not right, by the way.
It's negative 1x plus 5.
Yeah, so you can get from here to here without doing anything. You do it in your head with practice, lots of practice. I don't expect that from you. So I need a method. Okay, so here's the AC method, and we're going to do the AC method. You're going to see the AC method is longer. Okay, it is longer. It's just the way it is. All right, but it's the thing you can fall back on. And what I'd like to do is the AC method on both of these. All right, so you can see it. So I'm going to start with this one, even though most of you felt comfortable with it. The AC method goes as follows. You write your 3 terms in descending order. Highest power of x first, then the middle, x to the first power, then no x. So make sure it's in descending order. Recognize that there's a 1 out in front of that x squared. And what this is coming off of is this idea that we're looking at what's called a quadratic that looks like this. Okay, like all quadratics can be written like this, where you have a number in front of x squared, a number in front of x, and then a number by itself. So the AC method comes from the idea that the first thing you're going to do is multiply the a times the c. So you're going to take the number in front and multiply it times the number in the back, which a lot of you told me that's what I need to do to start. So I do the 1 times the negative 6, and I put negative 6 here in this little cross thing. All right? That okay so far? Then I take this number that's in the middle. What's that number? Negative 1, I put it here. Now I still have to come up with two numbers that multiply to be negative 6 and add up to be 1. That you cannot get away from. You're going to have to be able to think through those numbers. So what are they?
Negative 3 and 2.
It was negative 3 and positive 2, right? Negative 3 and yeah, be careful with that 6 and yeah. Negative 3 and positive 2. Those two multiply to be this and add up to be that, right? Now, here's where things are different. I'm not going to write two sets of parentheses right now. I'm not going to do that. Here's what I'm going to do. I'm going to rewrite the problem, x squared. And at the end, we had minus 6, didn't we? Okay. What I'm going to do now is I'm going to rewrite this middle term. That's minus x, right? That's minus 1x. But instead of writing minus 1x, I'm going to use these two numbers. And I'm going to write minus 3x plus 2x. Do you see how I'm using the minus 3 and the positive 2 to rewrite this as minus 3x's plus 2x's? If I put these two back together, I will get this, right? But why do you think that's useful to us, doing it like that? Now I have 4 terms, right? And how do we factor something with 4 terms? Grouping. So now what I can do is I can slash it here. And then I can pull. So it's kind of like we took something that wasn't complicated and we made it more complicated, right? We took negative x and made it these two. What we gained from it is getting 4 terms to do grouping on. Make sense? Now, what would you pull out of these two? X, what would you be left with there? X minus 3. What are we going to pull out of these two? Pull out a positive 2. We'll be left with x minus 3 again, right? And now, because we have x minus 3 in both, we can factor that out, and we would get x minus 3 times x plus 2, which is exactly what we got by just thinking through it, right? So if I were giving this on a test, if you can just look at it and do some number stuff in your head or on the side and just take it straight to the 2 parentheses, good. If you need to use this method where you turn it into a 4-term grouping problem, then do it that way. The advantage of this method is that it's going to work for this, okay? So if I come back to this one, let's do our AC method. You multiply 2 times 5, which gives you 10. What's the number down here? Negative 11. And now you have to still come up with those two numbers. What are they? Negative 10 and negative 1. So I'm going to rewrite the problem, but I'm going to make this negative 11x more complicated. I'm going to write it as negative 10x minus 1x using these two numbers. It does not matter which order you put these in. If you did it the other way around, you would still get the same result, which is good. Right? It would suck if we get 2 different answers if you do it 2 different ways. Okay, so what I have here is 2x squared. At the back I have plus 5. And in the middle now, minus 10x minus 1x. And then I come group. So what can I pull out of the first one? 2x. What would be left? X minus 5. Okay, this one's a little tricky. Over here, you actually need to pull something out that is going to leave you with an x minus 5, right? If you want this to work, this needs to be an x minus 5. Right now it's negative x plus 5, so you have to pull a minus 1 out. And now it matches. So what would our final result be here? X minus 5, right? And then parentheses, 2x minus 1. It does not matter which way you put those. Does that make sense? Sure?
I have just forgotten how to write it in the equation. I know you had to put it back in the same equation. I just couldn't.
Oh, you mean this insertion right in here? Yeah. And there's other ways. Trust me, there are other ways. I used to teach a way that was even quicker than this. but this, the faculty at this school have decided that when we want to do this factoring, to do this grouping method, because it just forces students to practice the grouping and just gets them better with the algebra. There is a way to do it, and I think someone had kind of the method. It was, you find the two numbers which were minus 10 and minus 1, but instead of putting like x and x here, like that wouldn't be right? What you do is you take this number out here, okay, and you put it in front of one of these and then underneath the other one's number. So I could do this. I could put the 2 in front here and divide that by 2. That's one answer. Or I could have done it the other way. This is the super shortcut way. The other way would have been x minus 10, x minus 1, right? But I could have put the 2 in front of this one and underneath that one. And this one right here matches this exactly. Do y'all see that? 2x minus 1, and then 10 over 2 is 5.
Oh, is that when you do, okay, so that's where you put, because I remember when you did that, it was like AB and then over C and then the two numbers divided by.
Yeah, you were on the right track to this one.
Fraction, you set it to x minus 1.
Yeah, so there, it's just, the thing about this, I used to do this all the time, but again, after talking with faculty, we're like, this is teaching someone how to do something they don't really understand why it's working. This is more like, hey, grouping, we already did this. Let's continue to practice it. So, whatever. All right, let's see, 12:55. Let's do a couple more of these. How about I do one more for you, and then how about we do a group quiz today, like a group activity. We don't have to call it a quiz. We'll call it a group activity. That way you don't freak out about it. And you work together to factor a couple of things and turn it in, and then we'll wrap it up with this today, okay? And then what we'll do is we'll come back next time and we'll do actual solving of equations, okay? So we get all the factoring done today, and then we come back and start solving equations next time, all right? So first let me do one example. Or you know what? Let me do two. Just because I need to show you something. Okay, so how about this one? 7x squared plus 16x minus 9. So I know some of you are really comfortable with this, and you're like factoring machine. I really think if right now you can look at that and go straight to this and get the answer without much thought, like you're way beyond where I expect you to be, So let's go through the process. What's the first step? Yeah. Okay, GCF, but if we talk about factoring, GCF, right? Count the terms. So nothing comes out of all these, right? Okay, so we have 3 terms, so we're going to use some sort of AC method. Because this is a 7 here, it's not as easy as if it was a 1. So I need to multiply here to here, and that's going to give me what? 63. And then, I'm sorry, 16? Negative. I don't know why I've 16. Yeah, you can't mess that up. Negative 63 and 16. Well, 9 and 7. Well, if we do 9 and 7, positive 9 and positive 7 don't multiply to be negative 63. They do add up to be 16, right? But they don't multiply to be negative 63. So that means I'd have to make one of them negative, right? But then they don't add up to be 16. So I don't think those numbers are going to work. So what happens if you run into a problem like this where you can't seem to come up with the numbers? Do you have something else? No? Can't take out the negative. No. Because if you pull a negative out of here, that changes that, and that changes that also. So it turns out that you don't save yourself from that. Okay. So yeah, let's try and break down 63, negative 63 into all its possibilities. All right, couldn't we do 1 and negative 63? Right? Those would multiply to be negative 63, but these would not even be close to this. How about negative 1 and positive 63? Yes, but they wouldn't add up to be 16. So then I would try to see what's the next number that goes into this. So 2 doesn't go into this, right, because it's not even, but 3 goes in. How many times does 3 go in? 3 and 21. But one of them has to be negative. So why don't I do this, and then I'll look at this one also. See these two possibilities? Do either of these add up to be 16? No. How about 4? Does 4 go in here? No. 5? 6? No. 7? Well, we already did that, right? 7 and 9. I could do one of those as negative. So 7 doesn't work. 8 doesn't go into here. 9? Well, we already did 9. So once you get to the point where you've already see that number in here, you can stop. So what does that mean? It's prime. This is prime. So I wanted to show you one of those before you got into your homework, all right? So there's a difference. There's a difference between something being prime and you just not being able to come up with the numbers. Like, just because you can't find the numbers, that doesn't mean it's prime. Like, if this was positive 63, then yes, 7 and 9 would work. And if you couldn't figure that out and you put prime, you'd be wrong, right? Understand? Okay. All right, so that is. So how could we fix this problem? Let's do another problem now. How could we fix this so that it would work? What could we do to tweak this problem just a little bit so that it would work for us? Yeah, why don't we just change that to a plus 9? Let's do a new problem, plus 9. Now we could do it, right? Because then our table becomes 63 and 16 and 7 and 9 would work. So what would I do here? What would I write if I'm going to use this table here? 7x squared plus 7x plus 9x plus 9. Okay, so just to be skeptical here, okay, I'm going to be a skeptic. What if I'm the student who did this? 9 and 7 instead. So let's see what they would have written down. That's what they would have written, right? Yes? See the difference? So would we arrive at the same answer? Let's see. I would slash this one here, slash this one here. So what would we factor out here? 7x. We'd be left with x 1. Over here, pull out plus 9, and then x plus 1. And then if we write x plus 1, 7x plus 9. Y'all okay with all that? Is that what this student's going to get? So what would we pull out GCF here? X. What would they be left with? 7x plus 9. And then over here, what would they pull out? Well, it's already 7x plus 9, right? But they have to pull something out. So 1, 7x plus 9. And now if they pull the 7x plus 9 out, they'll be left with the x plus 1, and it'll be this, but the other way around. So that's good news, that as long as you get the right numbers, it doesn't matter which one you write here in the table, the grouping will still work. All right, here you go, your quiz. Let's do this. Whoa, what the heck?
You want to know one per table or?
Let's do this. I'm going to give you a participation quiz. Okay, so I'm going to give you homework problems to work on, so you can check your answers later, all right? But I will give you 100 for being here and participating. But I want you to actually work, okay? And when you get these done, I'll let you leave, but I do want to see that you got to the answers.
As a group?
You can work together, yes. Let me just try and find where it is. I'm going to have to make this a little bigger. Oh. All right, so here's what we're going to do. Well, here's what you're going to do. Like I said, this is kind of giving you a head start on some homework. You see these problems 1, 3, 5, 7, and 9. You see how they have equal 0 on them. I want you to ignore the equal 0 for right now. And all I want you to do is look at the left-hand side as 3 terms, right? And see if you can factor them. Just those problems, 1, 3, 5, 7, 9. Okay, so those 5 problems. If it's prime, it's prime. If it's not prime, try and use your AC method or whatever you have. Everyone understand the instructions? Yes. This should be, let's see. Where is that? Do you want to have that? Well, just do those then. I mean, just do them. Yeah. Just do them. I know that they're going to appear somewhere here. Hold on. I'll find them. Yes.
When you get it set like that and you divide it by the 8 and it's and you can simplify, do you simplify?
Yes, you always reduce the fraction. Yes. Yeah, the numbers are going to be kind of big on that first one, huh? Do you have the packet with you, sir? Can I look at it real quick? All right, let me just see what's going on here. Okay, thank you. Your homework for tonight is page 59, but these problems are not on there. So these problems are apparently not in your packet, so it's just practice then. All right, that is it.